Okay, buffers. What's a buffer? A solution that resists pH changes. Resists pH changes. So, if you add an acid, it will neutralize the acid to keep the pH where it's supposed to be. If you add a base, it will neutralize the base to keep the pH where it's supposed to be. So, I'm going to give you 3 examples here. Let's say you have 3 buffers. You have buffer A, you have buffer B, and you have buffer C. You can make the pH whatever you want. We're going to talk about how to figure that out. So let's say this has a pH of equal to 4, this is a pH of equal to 7, and this has a pH of equal to 10. That's equal to 10. So let's say these are 3 buffer solutions. What buffers do is they maintain that pH of 4, 7, and 10. We're pretty close to it. So what that means is, and actually, I really just drew the pictures to have something to talk about. There's not a whole lot I'm going to actually change here or add to these pictures. But if I add H pluses to this, there will be ions in here that absorb those H pluses so that pH doesn't change. If I add OH minuses, for example, that's not really typical, but if I add a base to this, there's ions in here that will react with it to maintain a 4. Same thing here, same thing here. The only difference is this one's acidic to begin with, this one's basic to begin with, and this one's neutral. So, you've already learned all of what you need to know. We just got to put it all together. What could be floating around in these solutions that would neutralize acids and bases? Your blood does this, which is a really important thing. Your blood's a pH or a buffer. Blood's a little bit above 7. Why is it important that blood is a buffer? Why is that really important for our health? Because you could die, you get sick. Almost everything we eat has some sort of pH. Okay? Especially acidic. We eat a lot of acidic stuff. Salad dressing, there's literally vinegar in it. So your blood should be a little bit above 7. If you start ingesting a lot, some people drink vinegar. You put a lot of vinegar in your body, if your blood doesn't resist that and absorb those H pluses, the blood pH would drop, and that would screw up all the processes in your body that needs a pH of around 7. I don't know all the details and the biochemistry behind all of it or even specifics, but I know enough to explain the general concept that if our blood wasn't a buffer and the pH just wildly changed whenever we ate or drank anything, whatever functions going on in your body wouldn't work right. So you need a certain pH in your body. So it's really important that your blood absorbs acids and bases and reacts with them to maintain a pH of 7, or ish, around 7. So the only reason I drew these is that sometimes when I start talking about this, kids for some reason think buffers have to have a pH of 7. You can set your buffer at whatever you want. We're going to talk about that next period. All right? But again, this is probably the most important thing to remember today is what is a buffer. That's it. If you can remember what it is, it really helps understand all the other stuff we're going to be doing. So we're going to be doing calculations, ice tables, nothing new as far as math, but just understand the concept. It's a solution that resists pH changes. All right? And I have buffers, and I can show you hopefully tomorrow kind of how this works. All right, we got a couple minutes, so I'm going to introduce it here. All right, let's see here. Now, actually, let me ask you this question, Luke. So I should actually add to this a solution that resists pH changes when there's small amounts of acid and base added. So your blood's a buffer, right?
Yeah.
I just told you it kind of regulates. So if you add an acid to your body, it'll neutralize it. If you add a base, it'll neutralize it. So your blood stays around a 7. Okay, give me an example where you think that wouldn't work. So when you eat food and normal things, there's acids and bases and it can fluctuate, so your blood handles that. Give me an example of something abnormal someone could do that this wouldn't work for.
Drain cleaner.
There you go. You start pounding drain cleaner, all right? The reason it's really bad for you and you get real sick or die is because this doesn't work anymore. Basically what you're doing, no pun intended, is you're adding like 1,000,000 OH minus. So if you start, it basically drain cleaner is magnesium hydroxide, I think is common. So you're just pounding OH minus. That's not going to work. Your blood's not going to be able to handle that, so your pH is going to spike. Not to mention it's corrosive, so it'll start eating through your esophagus and your lining of your stomach and all that stuff. But this, I just want to make sure I say it, that it's small changes. Okay, we're talking like vinegar and salad dressing or baking soda. You know, small, weak acid, weak base, not strong acid, strong base. You start drinking hydrochloric acid, you're going to go this way. All right, your blood's not going to be able to resist that. So I just wanted to make sure I said that. All right, let's see here. Let me tell you how to make a buffer real quick, and then we'll take a break, and then we will continue. Okay, so a buffer needs an acid and a base present inside of it. So we need a conjugate acid and a conjugate base, or an acid and a conjugate base, or a base and a conjugate acid. What does that mean? Okay. How to make a buffer. How to make a buffer. All right. So there's a couple different ways. You can have a weak acid with its conjugate base, or you can have a weak base with its, conjugate base, or a weak base with its conjugate acid. So I'll give you two examples. You can have HC2H3O2 with C2H3O2 minus, or you could have NH3 with NH4 plus. Those are the two most common buffers. Oh, did I miss the bell? Am I not hearing things? All right, let's take a break.